In this problem, we want to find the greatest common divisor, or the greatest common factor, of two numbers using the Euclidean algorithm. And so we'll start with 3,500 and 550. And this is repetitive division. So we want to have the larger number underneath and the smaller number out front. Now I'm going to estimate this to be 3,600 divided by 600 and see if we can use 6. So 550 times 6, we will have 3,300, and so that will work out for us. So we have 6, and that's 3,300, and so we're left with 200 left over. So we then want to take our remainder and our divisor and work those into a long division problem. Again, we'll start with the smaller number out front as the new divisor and 550 underneath. So if we take 200 times 2, we're going to get 400. 200 times 3 is going to give us 600. 600 is too big, so we're going to use the 2 and get the 400 here. And when we subtract those, we will get 150. We then want to use 150 and 200 in our new division problem. So 200 divided by 150 is going to be 1, with a remainder of 50. And then we want to use our remainder and our divisor to create a new division problem. 50 as the new divisor, 150 underneath. That goes in perfectly. We have 3 times 50 giving us 150, and we got to 0. As soon as you have a 0 as a remainder, we are going to look to the previous remainder. The previous remainder is the greatest common divisor or the greatest common factor. So the greatest common divisor of 3,500 and 550 is 50. We can also, again, call it the greatest common factor. Those two are equivalent terms in this case. Next, we will find the greatest common factor, or the greatest common divisor, of 3,915 and 825. Start with the smaller number as the divisor and 3,915 underneath. And so this is a little bit more difficult. We have approximately 4,000 divided by 800, and so that is approximately 5. Let's see if that'll work out for us. 825 times 5, we have 25. That's 5 times 2 is 10, 11, 12, 41. That's too large, so we want 825 times 4. So that's 20, 8, 9, 10, and that is 3,300. So 3,300. Subtract that, we have 5, 1, 6, 615. So we have now our remainder and our divisor. We need to work those into a new division problem with 615 out as the new divisor and 825 underneath. That is only going to go in one time. And when we subtract those, we have 0, 1, and 210. 210. And 615 will be in our new division problem. 210, 615. That is approximately 3, but that might go over, so let's just double check. 3, yeah, 630 is over. So we want 210 and 2, which is 420. So 2 and 420. Subtract those. We have 5, 6, let's see, 195 is our remainder. So we have 195 and 210, that to be in our new division problem. 195 into 210. So that's going to go one time. And when we subtract those, we have 15, right? Because we have 10 there is 5. This is becomes a 0 here when I borrowed. And so that's now a 10. And there we go, it's 15. All right, so now we have our new remainder and our new divisor go into their own problem. So we have 15 into 195. All right, and so we're going to approximate that to 200 divided by 20. That's going to give us about 10 there. But I can, let's see, let's do 15 into just 19. And so that's about there. And we have 15 here. Subtract those, we have 4. Bring down the 5, we have 45. And so 45 divided by 15 is 3. That's 45 evenly. So we got our 0 remainder. So the approximation of 10 wasn't too off. It was a little bit off. So we got our remainder, which means we go back to the previous problem, and our remainder from the previous division is the greatest common factor. And so the greatest common factor of 3,915 and 825 is 15. You can also call it the greatest common divisor, and that is just as good in this situation, and it is 15.